Good morning, Math AH. We are going to do lesson 8.2E. So if you have your PDF printed or electronic or a piece of paper, and we're going to go ahead and start it down here on the second page. So we're talking about percent error calculations. This is going to be used a lot later on when you're in like chemistry. So it's something that's very applicable in science. So you need to learn it. Percent error calculations are used to determine how close the true values of experimental values really are. For percent error calculations, round your answers to the nearest hundredth. So an observed value is what you see in your experiment. Okay, you observe it with your eyes. So it's the value, experimental value. Okay, an accepted value is what we have like on the periodic table or a reference book or something like that. So this is the value found in reference tables. This is like agreed upon value from a lot of scientists or something like that. Okay, our percent error is to figure out what percent are we away from each other. So I'm going to go ahead and call my observed value OV. And I'm going to go ahead and call my accepted value AV. So when we calculate, we are going to go observed value minus accepted value over the accepted value times 100%. Okay, so I did the observed value minus the accepted value over the accepted value times 100%. So now we're going to do some problems. Ralph measures the mass and volume of a piece of copper in the lab. He uses his table to calculate the density of the metal. According to his results, the copper has a density of 8.37 grams per centimeter cubed. Ralph is curious to see about the accuracy of his results. He consults a reference table to find the accepted value for his density copper, 8.92 grams per centimeter cubed. What is Ralph's percent error? So to calculate percent error, we always have to figure out what is our observed value and what is our accepted value. And then we can figure out the percent error. So when I'm reading over here, his results have 8.37. The results are from the experiment, so that's what he saw, 8.37. And the accepted value is 8.92. So we have to go to the observed value, 8.37 minus 8.92 over the accepted value, 8.92. And then when we're done, we're going to multiply by 100. Okay, we don't worry that we're negative. A negative just means that he's lower than what was accepted. So what he measured over here is lower than what's in the reference table. So when we have a negative, we just know we're under what we're supposed to have. So we calculate that out. We're going to subtract. We get 0.55. And then we have to divide by our 8.92. Then multiply by 100. And we get that. We get negative 6.17%. Okay, so we know that our answer is percent error. So Ralph's percent error is negative 6.17%. Okay, again, asking what's a negative mean? The negative just means that he is under the actual value. The observed value is under the accepted value. Okay, so when we're finding the percent, it's a pretty straightforward calculation. Okay, next one. Working on chemistry, Kira finds the density of a piece of pure aluminum to be 2.85 grams per centimeter cubed. The accepted value of the density of aluminum is 2.699 grams per centimeter cubed. What is Kira's percent error? Okay, so this one's a lot like number 1. So I want you to relook at number 1, try number 3, pause the video, and then when you're done, check your answer. Okay, Kira finds, so I knew the finds was the observed value. That's what she did, 2.85. And then it's accepted, so I knew that this one was the accepted value. She's above, so I know my answer is going to come positive this time. I did my observed value minus my accepted value divided by my accepted value times 100. I subtracted, then I divided, then I multiplied, and then I rounded, and I got about 5.59%. Okay, next one. Gianna runs an experiment to find the specific heat of water. She determines the specific heat of water to be 4.29 joules per gram degrees Celsius. When she looks up specific heat of water in a reference table, she finds it to be 4.18 joules per gram degrees Celsius. What is Gianna's percent error? Again, this is a lot like number 1 and 3. So go ahead and try it and see if you can come up with the same answer, and then check the video. Okay, she determined, I knew that that part was the observed. And then it said she looked up in a reference table, so I knew this part was the accepted value. So I went my observed minus accepted divided by my accepted times 100. So I subtracted first, divided, multiplied by 100. Then I rounded. I got Jan's percent error is about 2.63%. All right, Molly ran an experiment in class. She found that she had a 15.6% error since the actual value was determined to be 25.7 milliliters. What are the two possible values Molly's experimental error measure? So we don't know if she is above or if she is below. So now we have to do some work. We are looking for, so again, I put down what I have, observed value, accepted value, percent. This time, she had the actual value, 25.7. And we have a percent, but we don't know if the percent is positive or negative, 15.6. And we're looking for the observed value. We're going to go ahead and call that x. So now we're setting up an equation. Again, we still set it up the same way. We have to go to the observed, so x minus the accepted, 25.7, over the accepted, 25.7, times 100, equals plus or minus, can't forget the plus or minus, 15.6. We have to solve this equation. So I'm trying to get the x by itself. Remember, we're trying to undress the x. So first, I'm going to undo the times by 100. So I'm going to divide both sides by 100. That's going to be my first step. So I'm dividing both sides by 100. So when I do that, I have x minus 25.7 divided by 25.7 equals, don't forget the plus or minus 0.156. Then I still want to clean up the x, so I'm trying to get the x alone. I have to get rid of that divide by 25.7. So on both sides, I'm going to multiply by 25.7. Okay, on this side, these cancel out. And I just get my x minus 25.7. On the right side, I actually have to sit there and multiply. So 0.156 times 25.7. Don't forget the plus or minus. I get plus or minus 4.0092. Then I still want to solve. So to get x alone, I have to add 25.7 plus 25.7 But now I have to do it 2 different ways because one time I'm treating the 4 as a positive and one time I'm treating the 4 as a negative. So I get x is equal to, so if I add it as a positive, 25.7 plus that number, I get about 29.71. Or if I treat the 4 as a negative, 25.7 minus 4.0092, I get about 21.69. Okay, so she's either high at 25.71 or she is low at 21.69. So Molly's observed value is either 29.71 milliliters, or that's if she was high, or if she's low, 21.69 milliliters. Okay, so we have to do a lot more work when we're trying to find the observed value or the accepted value. Okay, so here, George's calculation was found to have a 35.5% error. His experimental measurement was 15.6 centimeters. What are the two possible values for the accepted measurement? So on this one, I list out my stuff: observed value, accepted value, percent. I figure out what information I have in the problem. Okay, we have the error, but we don't know if we're low or high. So we have plus or minus 35.5. Okay, his experimental measurement. Experimental is the observed, so 15.6. And this time we're looking for the accepted, so here we put the x on this one. Okay, so we have to build our equation again. 15.6 minus x over x times 100 equals plus or minus 35.5. Okay, now this one's going to be a lot more work because we have x in the top and we have x in the bottom. So this is probably the hardest type of problem you get in these. Again, I'm trying to get the x's alone, so I have to undo that 100. So I'm going to divide both sides by 100. So when I do that, I get 15.6 minus x over x equals plus or minus 0.355. Okay, now if I have an x on the top and bottom, I have to cross multiply. So I'm going to go ahead and cross multiply, or multiplying both sides by x. So here I'm multiplying both sides by x. Okay, so here on the left side, the x's cancel out. I get my 15.6 minus x equals, here I get plus or minus 0.355x. Okay, I have variables on both sides. I'm going to move this minus x. So on both sides, I'm going to add x. Okay, this is where it gets tricky, so you got to pay attention. On the left side, I'm just going to have 15.6, not too tricky. On the right side, one time I'm adding it and it's positive 0.355x, and one time it is negative. So one time when it's positive, I would get 1.355x. Okay, but when it's negative, 15.6 equals, I'm going 1 minus 0.355x. So the other time I would get 0.645x. Okay, so that's the tricky part. That's the part that you have to go, whoa, what did she do? And pay attention. I had plus or minus. So one time it's 1 plus 0.355x, and one time it's 1 minus 0.355x. You have to have both cases. Then on each case, I have to divide by what's in front of the x. So on this top one, I'm dividing both sides by 1.355. And on the bottom one, I'm dividing by 0.645x, not x, just 0.645. Then I calculate, and then I'm going to get my answer. So in my calculator, 15.6 divided by 1.355, I get x is about 11.51. And over here, when I divide 15.6 divided by 0.645, I get about 24.19. So then George's accepted value is one of those two values. So I'm going to type that out. The accepted values value is 11.51 centimeters if George was high, or 24.19 centimeters if George was low. Number 7, the mass of a certain chemical was determined to be very precise, to be 1.42 grams, then measured on a classroom balance. The percent error was found to be 0.7%. What are the two possible values for the measurement in the classroom balance? So is the classroom the observed or the accepted? Last time I checked, we don't check those classroom balances very often. So that one is the observed. So we're looking for the observed. So I write out my stuff again. Observed value. Accepted value. Percent error. I'm looking for the observed value. I have the accepted value. That's the precise one, 1.42. And my percent, I don't know, it's plus or minus 0.7. Okay, so this one was the medium problem. It's kind of like number 5. So I want you to look at number 5, study it, try number 7, and then check the video again. Okay, so I went my observed value x minus accepted value over the accepted value times 100 equals plus or minus 0.7. Now we are going to be very, very close to the 1.42 because we're less than 1% away. So what we don't want to do is round our work while we're working. Otherwise, you're going to round off your answer basically. So first thing, I divide by 100. Then I multiply by 1.42 on both sides. Then I added 1.42, and this is where I have to pay attention. One time I have to add my little decimal, and one time I have to subtract it. So one time I got 1.42994, rounded it. That's about 1.43. One time I got 1.41006, rounded it. I got 1.41. So the possible values on the classroom balance were 1.41 grams or 1.43 grams. Again, your percent error is very, very small. So the difference between the actual and the balance is also very, very small. Last one, here we go. A professor used a standard mass to check the accuracy of the laboratory balance. The balance indicates the mass of 19.81 grams when the standard mass is measured. The professor found the percent error was 0.95%. What are the two possible values of how much the mass could weigh? All right, so again, I read the problem, and now I want to do my observed value and my accepted value and my percent error. I have to figure out what I am looking for. So I saw the percent error. That was plus or minus 0.95. Again, very close. Okay. We want to know what is the possible values of how much the mass could weigh. So here, he's checking the accuracy of the laboratory balance. Okay, so that's the observed value. So here, the observed value is 19.81, and he wants to know what the actual value is. So this is the hardest type problem. So you want to go back and study number 6 and try number 8, see if you can do it, and then check your answer. All right, so I went the observed value minus the accepted value over the accepted value times 100 equals plus or minus 0.95. Again, when we have the x in the denominator and the numerator, that's going to be the hardest type of problem. So first I divide it by 100. Then I have x's in the numerator and the denominator, so I have to multiply both sides by x. Now I have x on both sides of the equation, so I have to add x to both sides, but I have to be careful because this is plus or minus. So one time I'm going 1 plus my decimal, and one time I'm going 1 minus my decimal. So when I added it, I got 1.0095x, so I divided by 1.0095. I got this long decimal and I rounded. So one of my answers is x is equal to 19.62 about. On the other one, I had to divide by 0.9905 and I got exactly 20. So the two possible weights are 19.62 grams or 20 grams. So when we have the observed and the accepted values, easy to find the percent. Okay, if it's positive, it just means you're above. If it's negative, you're below, no problem. And then when we are looking for the accepted value, we've got the hardest type of problem because you have x in the numerator and the denominator. When you're looking for the observed value, you still have to solve an equation, but it's the medium problem. So you always have to pay attention. What did it give you? What are you looking for? And then go through your steps of solving your equation. All right, good luck. You've got the last homework for this section and then the review.